In this video, we will look at some use cases and examples from WATS that are relevant for startup companies. More specifically, we're going to look at how you better track and analyze the frequent test failures that you have, how you can investigate product returns and RMAs from your customers, how you can use WATS to improve the test coverage of your production testing, and how you can look at the extent of problems you get from product being retested. Finally, we're going to look at the dashboard components in WATS and discuss how these could be a tool that helps you actually spend less time looking at the data. So typically when you log into WATS, the first screen that you see is the dashboard. And we're going to return to this view in the end of the demonstration video. So now we're going to start with the yield report here. And what this does is it will break down the production yield metrics per part number that you have. So in the list, we can see here, we have three different part numbers. So we'll see 130P, 130C, and 130. And these two are tested in the PCBA test, and I will see 130 is tested in final function test. So the logic here is that actually the OLC 130 is the parent or the final unit. It consists of this P power module and one controller PCB here as well. On the right side, you can see the first pass yield metrics here. You have 85%, 100%, and 85% here as well. You can see how this compares to the previous period that you have, and you also see some volumes here. So if I would like to understand, to investigate what are the most frequent test failures for this OLC 130P product, I can use the action menu over here and drill down into other types of reports. So I can break this down by product revision, for example. If I go to this product and test yield, I can break it down by test station if I select this one. But for this demonstration, I want to look at this test of yield and analysis report. So after I select that, WATS will open us this new report. You can see that the filter is looks a little bit different. It's also going to pre-fill with the values based on the selection that I did in the previous step. It will ask me what kind of software sequence, file name and version do I want to look at. And in this case, I want to look at all of them. The reason why it asks for this is that the performance of each of the individual test steps may vary from between software versions, for example. Maybe you change test limits and similar. Down here in the blue Pareto, I'm going to see my top 10 test failures. So this, to the left, charge rate C31, it represents 160 of the failures, or 32% of all the failures that I have. The next one here, chroma measure current, it failed 97 times, and combined these represents 51% of all the failures that I have. So it's natural to assume that if I fix these frequent failures first, then my performance is going to be better. But in order to fix them, I need to understand more. I can't just know that they're a frequent failure. I need to know the details. So I can click directly here on this Pareto, and this will take me to the step details view. So this is a, well, as you can see, a very detailed view where you can see the trend of the measurements for this step. So down here, all of these blue lines are the individual measurements that we have per test report for this product. The red lines are the test limits. So one observation just now is that actually these failures looks to be happening towards the later side of the period. And this is also something that is confirmed here by the status chart. You can see the pass-fail status, where the fail status is overrepresented to the right here. I can group the data here based on certain parameters that I have. For example, product revision. And so now the brown line here is revision 10, and the blue line is revision 9. And you can also see now quite easily that although revision 9 has a lot of failure as well, the frequency of failures are far higher in revision 10. So maybe it is maybe we can conclude that this is related to a revision issue. But I can also investigate further, looking at repair information. So I'll select from this yield report here, I select the same product that we were looking at, but now I do a repair analysis query. So in this repair analysis report, I can look at the repair causes or repair codes based on a number of different parameters, like per part number, per failure type in the repairs, if that is like a manual process, an automatic process, if a component related issue, and so forth. I can look at the actual component numbers that you use, the article numbers from your vendors, component references in the designed failed test steps, test operators, and more. So now I've selected the component number report and the failed step report. And what I want to look closer at is actually this failed step report. So what test steps are you most frequently repairing against? Or what failing test steps are you most frequently repairing against? And charge rate C31, that was the problematic step in the that we saw earlier, is the one that has the highest frequency of repairs. I can expand on this, and you can see the repair codes that has been used. So insufficient soldering, no failure found are the two most frequent, followed by outside of specification. But the hypothesis from the measurement details were that this is related to revision 10 actually. So if I now go up here and I add revision 10 to this filter, I'll take away the component report as well. We can see here that charge rate C31 still the most frequently repaired report, but the most frequent repair code now is actually outside of specification. So it looks to be a component related issue where this capacitor that you test here does not perform as intended. Second example that we'll have a look at is to analyze units that are returned as failing. So what I can do here is that if I have a specific test operation that is RMA test, and typically that would be the case, or it should be the case, that you are able to distinguish a test from a product during production from one that is failing in the field, or that has been returned. So I'll then select here from test operation, I'll select RMA test instead of like PCBA and final function that we saw earlier. I'll apply this filter, and I can see these are the individual test reports that has been logged for the RMA test in the period that I am looking at. And if I go down here and look at the frequent failures in this, you can see both of them look to be related to power. So you have PCB power read, you have power on here as well. So what that leads me to believe is that maybe this is actually a failure that is related to the power board on this. And in this case, the policy is to also test the subunits. for the failure. So I know that the RMA test will also be done on this OLC 130p. And I'll rerun the report here. I'll get some new test results for the here the specific unit OLC 130p now. And the fail reason in all of these examples is this measure isolated 12 volt step. Here, down here I have some additional visualized information like the test operation, the operators that has been running the repairs, etc. I can also customize these if I would like to. But so what I'm interested in learning now is, okay, why are these one failing? Now, how did they look in or during production? Because the important question right now is this something that I could have picked up on before it was shipped to the customer? Because once that product goes out, specifically or especially if this is a consumer customer, then this is going to leave you at risk for negative reviews on Amazon Marketplace and similar. So it's important that you're able to detect the failures where they actually originate. So I can drill down into the process capability analysis report to better understand how the trend of these measurements were. But what I want to do here is I want to change this test operation now to PCBA test, because I am mostly interested in knowing how these measurements performed during production. So you can see here you have 2,700 units in the time period that I'm looking at. I'll apply this and I'll go down to this to the step, and it was measure isolated 12 volt if we recall correctly. And so there are two observations here. I'm not going to go into the details of process capability analysis, but to each of these steps they have an index called CPK here, and this is it's a ratio between the test limits and the 3 standard deviations of the actual measurement. So when they are low, it indicates that maybe the measurements are too narrow, or that that the test limits are too narrow, or that the measurements are fluctuating too much. So green, it's indicating that they're okay, and if they are blue, it's typically that your test limits are too wide. So you can see here CPK on this measure isolated 12 volt, it is 1. But if I go a little bit to the right here and look at this column, CPK without failed, if I take away the measurements that has failed, it is actually blue, meaning that there's a lot of room for what we call outlier measurements, that are deviating measurements not being detected by the test limits. So I can click on this here to open up the step details report that we saw earlier as well, and I can scroll down, and let me just toggle off this fail measurement switch here. So what we have here is the red lines are the test limits, and the dark blue lines, these are 3 standard deviations of the measurements that we are looking at. And typically, actually, 3 standard deviations are one of the guiding factors used when you determine what test limits you should be using here. If I look at the measurements here, you can see there are clearly some outliers. Again, this is during production. This has nothing to do with the RMA reports that we looked at. Yeah, so these are things that are outside of the normal distribution, and that probably has some negative characteristics, if you will. I can hover the cursor above this. I can also click it if I would like to see the serial number or the report here with the results. I can click here further if I would like to see the serial number history for this unit here. And okay, so you can see here it passed and it's failed afterwards in an RMA test. Now if I look at the serial number here, so you have 78, or let's just look at the last 3 digits, 599. I'll go to the test reports, the RMA reports, and yes, you can see this is actually a unit that has failed. And if I do the same exercise here for these other serial numbers, you can see that many of them has also been tested in this RMA test results or test process afterwards. So you found one specific test here that does not perform as it should be, and that leads to the consequences of failing products going out to the customers and being returned. And part of the reason why this tends to happen, and especially for startup companies, is how you determine the test limits here. You maybe look at the tolerance level at the component specifications that you have, and they have a value and a range, plus minus 0.5%, for example. But that is typically the worst case performance of this component. The actual stability may be far better than this. So if you just feed that directly into the formula that you use to calculate the test limits, it could be that you end up with a scenario here where the test limits are far too wide. And the reason why it's more, or typically more frequently happening at startup companies, is that you don't have that historical knowledge for the product for the product's performance to compare this with. If this was a second or third or fourth or fifth revision, maybe you would have been able to actually see this and input some offsetting factors into that test limit calculation. But when you have a brand new product being introduced, you don't have that historical comparison. The next scenario we'll look at is understanding retesting. So very often when you get a product from your subcontractor, you're under the assumption that they have been, everything that has a green flag or a past test reports are good products, but in some cases that is not necessarily the case. So in this periodic yield report in WATS, if you expand the different periods that you have, you will have a chart all the way down that will show you for all the units that has been tested good, but that did not pass in the first attempt, the first test attempt. When did they go through? So in this example, you have 24 units that were tested twice before they passed, 10 units tested 3 times. But you also have over here like a product being tested 18, 19 times before passing, and that is more problematic. It could be explainable in some cases, but it's still something that you need to be sure of, because at the end of the day, the product quality is your responsibility. So from here I can drill down and understand more about what are the underlying data here. So if I click on this 19, it's going to load the serial number history for this unit here. And what you can see here, you have a lot of failing test reports, obviously, because it failed 18 times. So September 23rd and like September 25th. Been tested a lot of times here. Then it eventually passed on September 25th here. Later it has been tested as a subunit in another part number, OLC 130. And if you recall from the beginning of this demonstration, that is the parent unit, the one that this power board PCB goes into. And this has also passed here. And later, it has also been tested as a subunit on this OLC 130 in a failing RMA test. So we know that this is a product that has been returned. I can again drill down into the test step yield analysis to learn more. Why did this product fail? Okay, so I've flagged it as something concerning, but I still need to know more information. Let me just clear the filter here and select all test runs. So one observation now is also that there are two different software versions used. So you have version 1.12 and 1.11. 1.11 has been tested once. But I'll just make a note of that, move on. Scroll down to the frequent failure Pareto, and it's only one failure, you can see actually. So all of the test failures comes from this charge rate C41. I can click on it to open step details view again. And here you can see the, so you have the high limit here, and all the measurements they're failing above the high limit of this test. But for the last one over here, the test limit actually went up. And this, if I hover over, you can see the OLC FT02 here. That's a station name for this. And if you look at all of the other ones, you would see that it's OLC FT01 that is the station name. So for some reason, this product was taken to a different test station that has different test limits. And then it passed. Built into a product, shipped to a customer, failed and returned. So you have a bad bad retesting culture here, but you also have a dissatisfied customer as well. So WATS will help you to get a quick understanding of how frequently are things being retested, and understand the root causes. Why are they being retested? What are the factors involved with this, so that you maybe can try and intervene and ask the subcontractor maybe to not do what you see here, at least. Okay, so I've spent about 25 minutes explaining and showing to you how you can use less time looking for production data, and that might seem a little bit counterintuitive. So that's why we'll have a look at the dashboard now, because this is actually one of the most important components in WATS for you that will allow you to spend less time looking at the data. So the dashboard gives you a quick snapshot of what is happening in the current period. So you can, for example, select the time intervals that you are interested in looking at here, 1, 7, or 30 days. And you'll customize this dashboard to show you the information that is most important to you. So this is an example of how it could look. You have some visualization of yield metrics over here that maybe for a startup is not the most relevant things, although you typically would like to be able to keep track of the last pass yield at least. Over here you have the frequent test step failures for the products that you have configured into the dashboard. So you can see that like DSP and LED issues are the most frequent things. So if you see changes in this dashboard, maybe that justify that now you should look into the data. Now you should try to follow the examples that I showed earlier, where you drill down and investigate this further. Down here you have a frequent repair category widget that shows what type of repair course or repair type is being done. So you like component related issue here. This is a yellow one. So this controller A12, it has 100% component related repairs associated with it. This widget here shows you the first pass yield, same information that we saw in the yield report as well. We can also see the trends. So this Sigfox product here, part number 290024, has a reduction in first pass yield, or more relevant, maybe a reduction in last pass yield of 7.3% in the last week. In the bottom, you have this event and alarm widget that shows you configurable alarm settings that you can make in WATS. So for example, the scenario that we saw with retesting, you can configure that to be a push notification. So if something is tested more than 5 times, or if something fails in a specific test, or if something is tested in the incorrect order, this will generate an alarm for you. You will receive an email, and it will also be available here on the dashboard. So it can be unit specific monitoring, but it can also be aggregated metrics such as drop in first pass yield or last pass yield. So again, the idea here is that you'll familiarize yourself with the data. You'll build these dashboards so that you can be proactive about it. You'll have something that will notify you when things are starting to trend the wrong way, and then you can react. Then you can go in and then you can analyze the data.